Dear students, in this presentation, I will explain you the basic concept of nanotechnology and its potential application. The idea of this unique field was proposed by a great physicist, Richard Feynman, in year 1959, with his famous quote, "There is plenty of room at the bottom," which indicated the possibility of direct manipulation of individual atoms in a more powerful way to create materials at nanoscale of your own interest. And this led to the foundation of the field of nanotechnology, and for which he has been awarded the Nobel Prize in Physics in year 1965. If we look at the definition of nanotechnology, it deals with the design, characterization, production, and application of various structures, devices, and systems by controlling the shape and size of material on a nanometer scale. 100 years ago, this field was known as art, and these two paintings, which are made on glass by using gold nanoparticles of various sizes, are shown here. The red color is due to the absorption of light by 20 nanometer of gold nanoparticle, and the orange color of the glass is due to the absorption of light by 80 nanometers of the gold nanoparticles. Thus, the different size of nanoparticle shows different optical properties, hence change in the color in when they absorb the light. This slide is showing a comparison of different organisms on a length scale, and nanotechnology deals with object having at least one dimension in less than 100 nanometer. And this is the area of the nanotechnology where it works. A nanometer is a billionth of a meter, that is 10 raised to power of 9. And this field works at extremely small scale, that is a nanometer scale, and which we cannot see by our naked eye. There are various objects which are made up by nature and in the nanometer scale, like human papilloma virus, which is around 50 nanometer in diameter, and these nanomaterials can be made into the laboratories. For example, Intel transistors, which are 40 nanometer in size, the carbon nanotubes around 2 nanometer in diameter, and the silicon atoms, which around 0.424 nanometer. Thus, the nanotechnology, which is based on the nanomaterials, which can be either naturally made, for example, DNA, proteins, or certain viruses which falls in the nanometer scale below 100 nanometer, and these materials can be made into the laboratories, and which we call as a engineered nanomaterial. We have a periodic table, and we can make the nanomaterials of the metallic elements or semi-metallic elements in the laboratory the way which we want. In real life, we do see the example of nanometer scale. A human fingernails grows 1 nanometer at every second, and man beard grows 5 nanometer at every second. The question arises, why nano? Why nanotechnology? And the answer is here. At the nanometer scale, the strange thing happens to the nanomaterials. and it is due to the rearrangement of atoms at that scale which leads to the change in the properties of the nanomaterials than the same material at larger scale. Coming to the nanometer scale, the reactivity of the materials is changed dramatically than their bulk counterparts. The different size of nanomaterials shows different optical properties, hence change in colors due to the absorption of light differently. The magnetic property of these nanomaterials also changes than their larger materials. Likewise, the conductivity, the electrical and electronic properties of the nanomaterials do changes when they come into the nanometer scale than the same material at the larger scale. And based on this, the whole nanotechnology has shown its potential for various applications to create improved devices, structures and systems. And here are the two examples which are showing the impact of nanoscale in terms of reactivity and size. If we compare the reactivity or water solubility of granulated sugar with a sugar cube, we found that the granulated sugar, due to the smaller size of the particles, they quickly dissolve into the water than sugar cube. And the size of the gold nanoparticle, when changes from smaller to bigger, it shows a gradual change in the color from pink to the bluish. Hence, it is the noble properties of the materials which arises at the nanometer scale which provides the driving force to the field of nanotechnology to be explored for the various applications. As the field of nanotechnology relies solely on the nanomaterials, on the engineered nanomaterials or created nanomaterials. A nanomaterial can be defined as an object having at least one dimension in less than 100 nanometer. In day-to-day life, we see the objects which are having 3 dimensions, height, length and width. But the nanomaterial can be created of 0 dimension, 1 dimension, 2 dimension and 3 dimensions. And here are some of the examples based on the dimensionality of the nanomaterials which have been engineered into the laboratory. The gold nanoparticles, fullerenes, which are made up of the carbon atoms or quantum dots, they fall in the range of 0 dimension. The nanotubes, nanowires and nanorods, they are one-dimensional nanomaterial. And the thin films, layered structures like graphene nanoseeds, they are of two-dimensional nanomaterials, and bulk nanomaterials or polycrystals, they falls into the three dimensions of the nanomaterials. Generally, two approaches are taken into consideration for the fabrication of nanomaterials, and these are top-down and bottom-up approach. In top-down approach, we begins with the larger materials, and by craving away or by sculpturing, we are end up with the nanomaterials of the interest. However, in bottom-up approach, which works in the reverse way, and here we assemble the smaller components, or we start from the atoms to build up the nanomaterials. The examples of the top-down approach is making a computer chip, and bottom-up approach is the synthesis of a metal nanowire. As our eyes has limitations that it cannot see the objects beyond 0.1 millimeter. So seeing the nanomaterials through naked eye is like experiencing an elephant by blind people. If a person with no functional eye touches the tail of an elephant, he realizes that elephant is like a rope. And if he touches the ear of the elephant, he feels it like a fan, and so on. And the same kind of experience we can have if we try to see nanomaterials through the naked eye. Therefore, advanced characterization tools are being developed to thoroughly characterize nanomaterials, their size, shape, and composition. In order to know the exact structure or shape and size as well as composition of the nanomaterials, various advanced characterization tools are being used, and these are the electron microscope, atomic force microscope, X-ray diffractometer, and other kind of spectrophotometer. By using these characterization tools, one can accurately tell about the size, shape, and composition of the synthesized nanomaterials, which is very important to investigate their further application in the various fields. On the basis of the novel properties of nanomaterials, the nanotechnology has found tremendous impact in various application fields ranging from technology to the medicine. The nanomaterials or nanotechnology are being used for making faster processors for computer and mobile applications and other powerful devices. The other area of application of nanotechnology is into the sports industry, cosmetics, in clothings, and making space elevators. This technology is further used to solve the environmental issues for making cleaner energy, better energy storage devices, water treatment, and so on. So the nanotechnology has a huge impact in the environment, and it can really solve the existing challenges in the field of environment. Nanotechnology has shown promising results in the field of medical sciences. A number of nanomaterials are being used for a range of medical applications, from cancer therapy to the disease diagnosis. The same properties of the materials which make them so useful for biomedical applications are also associated with a certain negative impacts on human health. Therefore, it is important to test the biocompatibility or toxicity of each nanomaterials before their application into the field of biomedicine. In the field of agriculture, the nanotechnology has been used for the increasing of crop productivity, improving the quality of soil, and stimulating the growth of the plant, and developing a smart monitoring system. Based on the above facts, it is concluded that small has a big impact. Nanotechnology has solution for most of the existing challenges in health, energy, and in the field of environment. Many more applications of the nanotechnology are still a matter of investigation. However, a safe and smart application of this field is highly recommended. Thank you for your patience hearing. Please drop me an email if you have any query at the given email address. Good luck.